ground. You can see the bits of the original substances, like in my trail mix or my salad dressing. They are both heterogeneous mixtures. You could say that a heterogeneous mixture is the least mixed kind of mixture. The other kind of mixture is called a homogeneous mixture. It does look the same throughout. See, in a homogeneous mixture, it's mostly water mixed with substances that are in tea leaves. And milk from the grocery store is a homogeneous mixture. Again, it's really made mostly of water, mixed fat, proteins, and a few other healthy things. Both tea and milk are mixed so well that you can't see the things that are in them. If you mix milk into your tea, you've created another homogeneous mixture.
We entrust it to you.
Here's a cool way to test the idea that mixtures can always be separated into their original ingredients. You'll need the following materials: a small amount of sand, salt, water, a coffee filter, a funnel, 2 beakers, a Bunsen burner with a ring stand, and some paper. Oh, and since we'll be using a flame, you must have an adult supervisor to help out. First, let's make a mixture. Start by filling the beaker about 1/3 full with equal amounts of sand and salt. Stir them up well so they are completely mixed. Then, carefully pour your mixture onto the paper. Here's the challenge: to separate the sand from the salt. You can try to do it by picking them out by hand, but I hope you've got about 1,000,000 years and a sense of humor. Relax, there's a more scientific way, trust me. First, pour the mixture back into the beaker. Then add enough water to fill the beaker about 3/4 full, and be sure to stir it well to dissolve the salt. Now we'll separate one of our ingredients. Place your coffee filter in the funnel and pour the new sand and the saltwater mixture through the filter into the other beaker. Let the water settle. See? The sand was trapped in the filter and separated from the salt and the water. But wait a minute. How do you separate the salt from the water? Place the beaker on the ring stand and have your adult supervisor light the Bunsen burner. And make sure you're all wearing goggles. Bring the water to a boil and keep boiling until almost all of the water is evaporated. Now look closely. What do you see at the bottom? The water is gone, but the salt is left. So there you have it. When you combine ingredients in a mixture, they can always be separated. When you mix lemon juice and sugar in water, they dissolve. They break apart and mix completely with the water, just like the salt in our lab world experiment. When this happens, a solution is created. A solution is another way that different substances combine to make something new.
Ready to ride?
It's actually the best mixed kind of homogeneous mixture. All solutions are made by dissolving things into other things, usually liquids. Take lemonade. It has 3 ingredients: water, lemon juice, and sugar.
Oh, no!
Whatever is being dissolved, in this case the sugar, is called the solvent.
Ready to ride?
Whatever is doing the dissolving is called the solvent. Here the water and the lemon juice are both the solvent. A solution is all mixed evenly, which means that every glass of lemonade tastes the same. But it's important to remember that a solution is still a mixture. So, while all the ingredients in my lemonade are very well mixed, their properties do not change.
For riding with us.
Now that I knew the basics of elements, compounds, and mixtures, it was time to figure out how to use this knowledge. When we talk about the health of our environment, what we usually mean is the amount of pollution in our air and water. To find out just how much toxic material is in a river, for example, we test the water. Today I'm tagging along with my friend Jody as he tests the water in this river. Rivers, lakes, and oceans are actually giant mixtures. All kinds of stuff, like dirt, leaves, branches, and even chemicals can get mixed into the water. Using special equipment, it is possible to tell just how much of a particular chemical is in the water. And we are happy to report that the water is clean. I thought this would be a cool job.
Go for it!
My newfound knowledge about mixtures and compounds is not new thinking. It seems pretty simple to make a
It's
mixture.
gonna be alright.
You just mix
Okay,
things,
just
like
keep
trail
trying.
mix, or lemonade, or a smoothie in a blender.
It's gonna be
But
alright.
how do you go about making a compound?
Just keep trying.
Well, what I learned was this. Chemical bonding requires a chemical reaction. That's what it's called whenever bonds between atoms are either created or broken. And a chemical reaction usually requires a lot of energy, in the form of heat or electricity. When you burn wood or paper, the heat breaks the chemical bond, and what's left is carbon in the form of soot and ashes, and water in the form of water vapor that floats away as smoke.
Great!
Ancient scientists, called alchemists, tried to use chemical reactions to turn ordinary metals, like lead, into gold. Those early chemists may not have understood exactly how chemical bonds worked, but they did know one thing that is true. A chemical reaction will create a new compound, or break down an existing compound into its original elements.
One day. It was a plan. It was supposed to be a plan.
One of the most fascinating examples of how compounds are used in our world is glass. I visited Mary Edgar's glass blowing studio to learn how it's made. At the heart of all glass is a compound called silicon dioxide, better known as silica. Silica is the most common compound in the Earth's crust, and it's formed when one atom of the element silicon bonds with two atoms of the element oxygen. It's what most of the rocks in the world are made out of, and what most of the sand on the Earth is made of. When silica sand is heated to very high temperatures, it melts and forms silica glass. Once it's in liquid form, other ingredients can be added to make just the right kind of glass for the job at hand. As the glass cools, it can be shaped and stretched into all kinds of things, by expert hands, of course. Day 59 of my science quest wrapping up. Today I got down to the basics of everything in our world. I learned that an element is a unique and pure substance in its simplest form. Every atom in an element has the same number of protons. That's what gives each element its own unique set of properties. When atoms from two or more elements chemically bond together, they form a new substance, a compound. I learned that when atoms bond, they form molecules. That's what compounds are made of, and every molecule in a given compound is the same. But remember, for bonding to take place, there needs to be a chemical reaction, and that usually requires heat or electricity or tremendous pressure. I also found that elements can combine without chemical bonding in mixtures. A mixture is two or more substances combined without a chemical bond. And there are different kinds of mixtures. Heterogeneous, the least mixed, like salad dressing, and homogeneous, really well mixed, like milk. And solutions. That's when one substance actually dissolves into another substance, like the solid lemonade. Because it's mixed so well, a solution is the same throughout, even though there was no chemical reaction. I'd say it was a day packed full of elements, compounds, and mixtures. Take a look around you and think about it. Everything you see, more than 20 million substances, is the result of these combinations. And those are just the ones we know of. So long for now, your fellow traveler.
I thought it was good.
Oh no!
You hit right here last week. How long last time?
Well, basically 2-1 then. Because I won. Wait, I won the first time. I won the second time.
Good afternoon, Wildcats. Please listen